A very important part of chemistry and almost any science is dimensional analysis, or the factor label method of calculations. Um, this week, we're going to use this method to convert measurements into different units. And let me show you how this is done. I also post some videos from Melissa Maribel, who has a slightly different way of showing you. It's quite similar, but slightly different. I recommend you watch my video and Melissa Maribel's video. You might get it better from Melissa Maribel, but my video is the one that is working on the problems that you're working on. So here we go. A certain radio station, blah, 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 136 inches long, convert this wavelength into meters. Now, here's how you do this work. There are two numbers here, so I don't know which one to start with. So I'm going to start with the unit that I want. I want meters, and I see here there are centimeters. So I'm going to write down meters. So let's see. In a certain number of meters, there are a certain number of centimeters. Right? I start the problem like that. Why do I start the problem like this? It's because I know I want meters. Therefore, I start with meters. This is just one way to approach this problem. Watch Melissa Maribel's videos to find a different way to approach the problem. Okay? Now, I'm starting with meters, and meters is related to this problem because there are centimeters here. Now, how many meters are there in a centimeter? Let's see. I took this figure, this table, from a different textbook, but it's still useful. Let's see. Centa anything is 0.01 thing. So centimeters is 0.01 meters. All right, so centimeters, 1 centimeter is 0.01 meters. That's how you use that table. Then I need to get rid of the centimeters because I want meters, not centimeters. I had to put this here in order to relate meters to what is given in this problem. Now, what have I got that's centimeters? I've got 2.54 centimeters. So if I put 2.54 centimeters up here, I'll be able to cancel centimeters out. But I need to relate this to something else in this problem. 2.54 centimeters in 1 inch. In 1 inch. Okay? 2.54 centimeters is 1 inch. That's good. Now, how is this inch related to the problem? Well, I start with this data, 136 inches. 136 inches. This number is related to the problem because it is the given information. I don't have to relate it in any other way to this problem. So the inches just cancel out, and I get an answer. I'm going to get this answer for you. It is 2.54 times 136. So this is going to be 2.54 times 136 times 0.01, and that's 3.4544. 3.4544, and the units are meters. Meters? Okay. Now, to type the answer in here, I'm going to have to round this off to the correct number of significant figures. This 2.54 centimeters in 1 inch, I'm giving this to you as a definition. So you should consider this as a definition. I don't think this is actually the standard definition that's used all over the world, but for our purposes, let's just assume this is the definition. Then you do not count significant figures here because definitions are like counts where you have an infinite number of significant figures. This is not a measurement, in other words. Right? So what are the significant figures? Here they are, 3 significant figures. 1, 2, 3. That means the answer can only have 3 significant figures. This only has 1 significant figure, but it is not a measurement. It is a definition that I obtained from this table. Okay, so I can only have 3 significant figures, so I'm going to type in here 3.45. 3.45, and I'm going to move on. Number 2. In number 2, let's see, it looks like it says convert this to femtoliters. Volume of a single human red blood cell is that many liters. That's a very small number of liters because the exponent is negative there. So let me convert this to femtoliters. To start this problem, I'm going to start with femtoliters. How many femtoliters are there in a what? What is this problem using? It's using liters. Okay, How many femtoliters are there in a liter? So femtoliters in a liter. Let's go up there and get the femtoliters. Femto. There is, that's way too many zeros. I can't write that. I'm going to skip one or something. Here we are. 10 to the minus 15. On a calculator, that's going to be as 1 times 10 to the minus 15. So 1 femtoliter, 1 femto something, is 10 to the minus 15. 1 times 10 to the minus 15. I put the 1 times here because it's very convenient to use your scientific calculator with scientific notation instead of typing a 10 to the power of negative 15. Right? So I've just connected femtoliters with liters. The reason I did that is because liters are in the problem. I'm going to put liters here. 9.4 times 10 to the minus 14 liters. All right, so the liters cancel out. I do not have to connect this to anything at all because this is the given information and it is not connected to any other unit here, any other quantity. All right, so this is just going to be everything on top multiplied, everything on the bottom divided. So 9.4 e minus 14 divided by 1 e negative 15. So that's 9.4 minus, I can't use minus, it's the negative. Negative 14 divided by 1, negative 15. Okay? The answer is 94. The answer here is 94, except it's 94 actually. The liters are crossed out, so it's 94 femtoliters. 2 significant figures here, 2 significant figures here, so we're good. I'm going to type the answer as 94. And number 3, okay, now so far I have been approaching these problems by putting what I want first so that I can be sure that at the end I'm going to have what I wanted. All right? Your textbook, the Revell textbook, and also Melissa Maribel don't do things that way. Melissa Maribel and your textbook put what you have first. So if we go back to number 2, the way they would solve this is they would put 9.4 times 10 to the negative 14th liters first. And then they would say, well, let's get rid of the liters by putting liters in the bottom, femtoliters on top, and in 1 femtoliter there's 1 times 10 to the minus 15 liters. You end up with the same answer, it's just the approach is different. You can use whichever technique you like. The reason why I prefer this technique where I start with what I want at the end is because when problems get very complicated, sometimes I have a hard time figuring out which quantity, which number to start with. For example, look at this problem. There's a number here, and there's a number here, and there's a number here. There are 3 numbers here. Am I going to use them all? Which one do I start with? Not sure. So in a case like this, I like to use the technique where you start with what you want. Let's do that again. So let's do number 3 here, using my technique. You can use whatever technique you like. I'm going to keep on saying that. All right, so I want inches. Convert this to inches. So I'm going to start with inches. Now, what are inches related to in this problem? Let's see. The length is 54 decimeters. Now, inches is a length. And, oh, look, 2.54 centimeters in 1 inch. All right, so obviously I can use centimeters. So in 1 inch, there are 2.54 centimeters. Right? Now, decimeters are also a length. All right, it says the length is this many decimeters. So I need to convert centimeters to decimeters. I happen to know that there are 10 centimeters in 1 decimeter, but you see, this table doesn't have that information directly. Using this table, I can only convert centimeters to meters. Oh, so let me do that. So 1 centimeter, using this table, centi means 0.01, so is 0.01 meters, all right? Centimeters cancel out. This problem doesn't have centimeters, it has decimeters. So I can use this table again to get decimeters. So 1 decimeter is 0.1 meters, right? So 0.1 meters, 1 decimeter. Why did I put meters on top? It's because I want meters to cancel out with meters that are already on the bottom, right? So now I've got decimeters on the bottom. How can I get rid of decimeters? I can get rid of decimeters by using what they gave me, 54 decimeters. There's no other number associated with this, just 54 decimeters. That's given data. So I'll just write 54 decimeters, cancel out these decimeters, and the answer is everything on top is multiplied, everything on the bottom is divided. So it's 0.1 times 54, divide 2.54, divide 0.01, right? Watch the calculator work. This is not intuitive, right? 2.54 times, what was it again? Oh no, it was 0.1 times 54. Sorry about that. Okay, so it's 0.1 times 54 divided by 2.54. Last number is 0.01. Divided by 0.01. Did you see that? I pressed the divide sign twice. It is not 0.1 times 54 divide 2.54 times 0.01. No, it is not times 0.01. Unless you use parentheses, if you put times 0.01 in your calculator is going to think you meant that 0.01 is up here. You have to type divide 2.54. Okay, let's get rid of the. You have to either use parentheses or you type divide 2.54 and divide 0.01 the way I just did. Over here. Over, where is it? Over here. Divide 2.54, divide 0.01. And I get the answer of 212.59 or 212.6. 212.6, and what are the units? Everything is crossed out except for inches. Units are inches. Now, this is infinite significant figures because it's a definition. Same thing, definition, definition. This is the measurement, 3 significant figures, so I can only have 3 significant figures. This is 5 and above, so I give this number a shove. 213 inches, that's my answer. 200, so I type the answer 213. I type submit, I click on submit, and I check the results. It looks like I did it right. I got 5 out of 5. Boom, boom, boom. Now, when you do this, the numbers are going to change. And I expect you to do this over and over again until you get 5 out of 5, but it's totally up to you. I mean, it's not like I'm your dad. You do whatever you want. But I recommend you do this over and over again. And the reason I recommend that is because the skill here, this type of work, whether you do it my way or the book's way or Melissa Maribel's way, very important for this class. In fact, for any science class. It's even important for the NCLEX exam for nurses, this dimensional analysis skill. Thank you. Bye.